trinomials. And so up here on the board, this is something that if you can recognize, great, but it's something that you may not need to use. You can factor it any other way. So first of all, a perfect square trinomial, basically your first term here has to be a perfect square. Your last term here has to be a perfect square. Okay? So what is squared to give me 16x squared? 4x. What is squared to give me 9? 3. So if I take 4x times 3, what do I get? 12x. If the middle term is twice 12x, that's a perfect square trinomial. Okay, so how do you get 24? You take 12 times 2. So this is a perfect square trinomial. So how we factor it, it's whatever the first term is plus whatever the last term is, quantity squared. Okay? So pretty straightforward.
What if the first and the third numbers aren't?
Then you can't, then it's not a perfect square trinomial.
You just say like what you say then.
Well, you'll see on our example, okay? Alrighty, so here are some examples. Determine whether each trinomial is a perfect square trinomial. Write yes or write no. Okay? So the first one, 4y squared plus 12y plus 9. So if we're determining if it's a perfect square trinomial, I find is the first term a perfect square. What is squared to give me 4y squared? 2y. Is the last term a perfect square? What is it? 3. So now what I do is I take the product. What is 2y times 3? 6y. If I can double that and get the middle term, double it, do I get the middle term? So this is a perfect square trinomial. Just for kicks, how we would factor that, it would be 2y plus 3 quantity squared. Okay. All right, let's look at the next one. So is 9x squared a perfect square? What is squared to give me 9x squared? Is 4 a perfect square? What is squared to give me 4? What's 3x times 2? 6x. Is the middle term twice 6x? No, so this is not a perfect square trinomial, and we can't factor it using the perfect square trinomial pattern. Okay?
Wait, why doesn't it work?
Because 6x, yeah, you didn't double this to get the 6.
Okay.
All right, let's look at this one. 9y squared plus 24y plus 16. Okay, so first, is 9y squared a perfect square? What is squared to give me that? Okay, what about 16? 4. So now I take 3y times 4, which is 12y. Is the middle term twice 12y? So this is a perfect square trinomial. How would I factor that? 3y plus 4, quantity squared. Let's look at the bottom one. 2a squared plus 10a plus 25. 2a squared plus 10a plus 25. Yes?
Okay, why is it 3y times 4? Because isn't that what you do to get your 12y?
0 plus 4. And then you multiply that.
Yep. So let's look. Is 2a squared a perfect square? Nope. So is this a perfect square trinomial? Nope. There you go. Okay, so let's look at this one. Now this one's going to be factoring in general. So this is going to kind of be everything we've discussed all about factoring. So if it cannot be factored, we write prime. So the first one we're going to start with is 5x squared minus 80. So the very first step, whenever we factor, what was the thing I always had you look for? Is there something in common? So is there something in common that I can take out there?
Yes.
A 5. Yep, so let's take a 5 out. So if I take a 5 from 5x squared, what do I have?
X squared.
x squared minus, if you take a 5 from 80, 16. So now we're looking specifically inside the parentheses. And whenever I have two terms, I look for the difference of two squares.
X
Okay, so is x squared a perfect square?
and
Yep. Is 16 a perfect square? Yep, so if you remember, how do I factor x squared minus 16?
it's x plus 4, x minus 4.
X plus 4 times x minus 4. Now, could I write that as x minus 4 times x plus 4? Yep. And there you go. Okay, let's look at the next one. 2 times x squared minus 32. I want you to try this one for me. Okay, so you're going to notice this looked real familiar to the problem right before. This is what you should factor to be. First thing you can take out is a 2. Once you take that 2 out, you should have x squared minus 16, in which case that's how you can factor that. Questions?
No.
Pretty straightforward on that one. Let's now look at this one. 9x squared minus 6x minus 35.
Question. So with like a problem like this has 3 numbers, and so it's gonna have like 3 of those parentheses, right?
No, and you'll see.
Okay.
Okay, so first of all, 3 terms. Is there anything I can take out that's in common?
Yes.
Nope, there's nothing I can take out that's in common. So the next thing is I can try to see if this is a perfect square trinomial. Is it?
No.
Why not? Because the 35 is not perfect square. So now, this is my other option. Okay? This number here isn't 1. So since this number here isn't 1, we've got to do a little bit of work here. So what I need to do is take first times last. So what's 9 times 35? And this is where your calculator is probably going to be handy. So what is 9 times 35? 315. Okay? So 315, I'm looking for 2 factors of 315 that differ by 6. So let's start figuring out what are 2 factors of 315 that differ by 6. Now some of you are wondering, how do you do this? Start typing it in. 315 divided by 3, 315 divided by 5, 315 divided by, and when you find 2 that differ by 6, what'd you get? 15 and 21. So it's just kind of a process of where you're just going to have to kind of try to see which ones work. So we've got 15 and 21. Now we have to figure out, how do you get a negative 6 from 15 and 21? Negative 21 and positive 15. Okay, so let's revisit what I did. I took first times last. I got 2 factors of 315. They differ by 6, so I have 15 and 21. I put my signs in now, so I get positive 15, negative 21. This next step I'm going to write out. I'm going to let you look at it, and then I'll explain what I did. Okay, all I did is I rewrote the middle term right here, negative 6, and I used these 2 numbers right here. Because if I add positive 15 and negative 21, you get negative 6. So all I did is I used those 2 numbers, put them down here in the middle. Now, do we remember what happens when we have 4 terms? What do I do? Pair them up, like they're couples. Okay, so see, now you see why we did this 4 terms. What is in common with the 9x squared and the 15x? 3x, nice job. What does that leave me with? 3x plus 5. Okay,
-7.
yep. Negative 21 and negative 35 is negative 7, and that leaves me with 3x plus 5. So we look and we see that these match. Yeehaw. And so that's one of our first quantities. What's our other quantity?
3x minus 7.
3x minus 7, the ones on the outside. Okay?
You don't do the, what do you do 3x plus 7 and 3x?
Alrighty, we're going to look at another one of those, definitely. Okay? But you can kind of see how everything we've done is kind of building on this one. Okay? Because we kind of used a little bit of everything we've learned. So I have 12x squared plus 5x minus 25. So first things first, we have to go through the steps. Can I take out something that's in common? No. Is this a perfect square trinomial?
Yes.
No.
Why not?
There's 12.
Because the 12's not a perfect square. The 25 is, but the 12's not. So then now, I look here, this is a 12, so I'm going to take first times last. So what is 12 times 25?
300.
300. So let's figure out two factors of 300 that do what? Differ by 5. What are two factors of 15 and 20? Good job. Okay, so I've got 15 and 20. My next step is to say, how do I get a positive 5 from 15 and 20? Positive 20, negative 15. Now, does it matter the order in which I have these? Could I write the 20 first and the 15 next? Yeah, you can. You're just going to have some different steps, but you will end up with the exact same answer. So my next step, 12x squared, and then what comes next? Minus 15x, keep going, plus 20x, minus 25. Nice job. What do you do now? Group them. What can you take out from the first group? 3x, and that leaves me with? What's it leave me with? 4x minus 5. What can you take out from the second one? 5, and that leaves me with? 4x minus 5. Next thing, let's compare. Those match. Very good. So then I know that one of my factors is 4x minus 5. What's my other one? 3x plus 5. Nice job. Questions? Okay, let's look at this one. Solve. So now we're going to throw this equals 0 stuff in again. Now today's a little bit longer lesson. I can tell you that tomorrow isn't going to take us very long. Okay, tomorrow I just have a few slides as opposed to, today, which we have more slides. Okay. So now, first thing, can I take out anything that's in common?
Well, they're each this first and the third of those.
So is there something in common with all three terms? No. So then I look to see if it's a perfect square trinomial. Is a squared a perfect square? Is 36 a perfect square? Okay, so I get a and I get what? 6. So let's multiply first and last. What do you get? 6a. Is that a perfect square trinomial?
Yes.
You bet, because if I double 6a, I get 12. So remember, in order to solve that or write that as a perfect square trinomial, what would I get? A plus 6. Remember, all the numbers we use are just in this first row, the a and the 6. And we're going to show that that equals 0. Okay? So now for those of you who are kind of wondering, well, what do you do with this squared? If you square something, all that means is that you take it times itself. So maybe that makes a little bit more sense. Okay? Would you agree that if I say that a plus 6 equals 0, I don't need to write the second one down? Because it's the same thing, it's identical, right? So it's really like I just have the 1. And so I've got one solution here. And how do you find the solution? Subtract 6, And so what does A equal?
-6.
-6, and there you go. So whenever you have a perfect square trinomial, you're only going to have one solution. Okay, let's look at another one. Let's look at this one. 9x squared equals 49. And this looks real familiar with one of the ones you had on your worksheet yesterday that we looked in class. Does anybody remember what we did with that one we looked? Yep.
Subtract 49.
Perfect. We subtract 49 from both sides. So I end up getting 9x squared minus 49 equals 0. First step, is there something in common?
No.
Answer is no. So since there's nothing in common, I've got two terms. I think, okay, is this the difference of two squares?
Yes.
So what is 9x squared? 3x. What about 49? 7. So I've got my two quantities. Do we remember what will go in each of those quantities?
3x minus 3x.
Okay, 3x minus 7, 3x plus 7. And remember, I could have those switched too. I just went with the first one I heard. So now in order to solve that, either 3x minus 7 equals 0 or 3x plus 7 equals 0. So in order to solve this, first thing I'm going to do is add 7. So I get 3x to equal 7. What do you do then? Divide by 3. So what does x equal? 7/3. Okay. Over here, I'm going to do the exact same thing, except for instead of adding 7, I'm going to subtract 7. So I get 3x to equal -7. And so what do I get x to equal? -7/3. Okay. Questions? Let's look at one more. X plus 4 quantity squared equals 64. Okay?
Can we just write down x plus 4 twice minus 64 equals 0?
You could. I'm going to show you another way that actually works a little bit better, I think. Okay. Because it's Alrighty. So first things first, what I'm going to do is I'm going to go ahead. I take that back. I'm going to change gears. X plus 4, x plus 4. Kind of what you already had said. Okay. We're going to FOIL that out. So go ahead and FOIL that out for me. And when you FOIL that out, what do you get?
X squared plus 4x plus 4x plus 6.
X squared plus 4x plus 4x plus
Sorry,
16. Okay. So I end up getting x squared plus 8x plus 16 equals 64. So now what I'm going to want to do is move that 64 over. Okay, so I'm going to subtract 64 from both sides. So I end up getting x squared plus 8x, and then what?
Plus 16 minus 64.
Right, which is? -48. Yep, equals 0. So now, can I take out something in common?
No.
Is it a perfect square trinomial?
No.
No. So then now I look, and this is the number 1. So this is a good thing, because if we remember this, when we factored these before, remember all we did is we could jump right here. to our solution. Do we remember what went first in each of these parentheses? An x. An x went first because that's how we get x squared. We take x times x. And so now I look at the last term. 2 factors of 48 that differ by 8. 2 factors of 48 that differ by 8. 12 and 4. Now remember, I attach signs now. How do I get a positive 8 from 12 and 4? Positive 12, negative 4. So remember, one of these is plus 12, the other is negative 4. And so now I need to solve each of those individually. So x plus 12 equals 0, or x minus 4 equals 0. What's your first solution going to be? X equals negative 12. Okay. What's your next solution going to be? X equals 4. Now there is another way to solve this, and it's by using something known as the square root. Actually, positive and a negative square root. So don't think this is the only way. Okay, but I think this is probably the way that we need to stick with. So any questions?
When you went from x plus 4 to
Yep.
the next part,
Yep.
like, how did you get to 16?
Because I took first times first. That's where the x squared. X times 4. 4 times x. And then 4 times 4. Okay? Any others? Alrighty, this is what you need to work on then. Page 526, 527, 12 through 33, all.